Hey everybody, Mr. Morrell here, and we're going to talk about solving two-step equations. Now, all of the equations we're going to see here can be solved in two steps, and sometimes those steps will look kind of different from one another. But if you watched my last video and I introduced the box of doom method, if you're good at the box of doom, you're going to have such an easy time with this homework assignment. So the box of doom was kind of silly seeming in the last episode or the last video that I made, but really it's going to help you so much here if you are mastering that. Let's go ahead and start with this level 1 question. Here, the question says, I solved the equation 2x plus 1 equals 7 and found that x equals 3. So, in class we've been talking about making a claim, okay, and showing your evidence, and then checking your work, okay. What we're doing here is I don't need you to show me the evidence. I already did the work and I said the answer. I want you to make a claim to prove that you understand what the answer means and to check your work, because it's such a good habit with these questions to check your work. Now remember, a claim is a complete sentence in which you kind of take your question and you put your answer into it. It's a sentence where you're saying your answer in relation to the question. It's a complete sentence. So I don't really like to write on the iPad. You guys already know that. So I'm just going to give you an example of what I would probably say is my claim. I'm going to tell you what the answer means in a claim. So to me, what this answer is saying is this. 3 is the only number that x can equal. That's this part here. So 3 is the number that x can equal that would make this statement true. Okay, let me say that again. 3 is the number that x can equal that would make this statement true. And that is also going to play into checking the work here. So what I'm trying to say in my claim is if I take out the x and put a 3 in its place, and maybe that's a different way to make a claim, actually. That's a good way to say the claim. If I take out the x and put in a 3, then this statement would be true. That's another way that you could have said this claim. And it's a great way to check your work. So I'm going to do that. I took out the x, I put a 3 in its place. 2 times 3 is 6, plus 1, and then 6 plus 1 is 7. Well, that's totally a true statement. 7 equals 7. That's a good true statement there. Okay, so you need to write a claim in your own words, probably label it as your claim, and then maybe over here on the side you can check your work the way that I just barely did. All right, so let's go ahead and jump in and start answering these questions down here. All right, so again, I'm going to use the box of doom method, which means if you see a letter, you only see one copy of that letter, the one that we're trying to solve, we're going to start by making a box. And this seems a little dumb now, but I put the letter on top of the box to remind myself which letter I'm solving for. Right now we only have one letter, so that it kind of seems silly, but it's a good habit to get into. And what's going to happen is we're going to start closest to that letter, and working our way out, we're going to list the different numbers we see on that same side of the equation. So we're going to list those numbers, and we're going to say what operation is happening to them. Alright, so what I mean by that is here we see this x. Well, the closest number to it is a 5. And that 5 is like they're being multiplied together. So x, the first thing that's happening to x is it's being multiplied by 5. Then as we move farther away, it's also being added by 14. Now here's where the box of doom really comes in handy. Most students have a hard time knowing what order they should be solving this in. Like, what do you do first? I think that's usually your question. So if you have set up your box of doom like this, the answer is you're going to always start at the bottom of the list, work your way up, and you're going to do the opposite operation. Again, I know that I'm one of the only teachers that teaches this, so if this is totally foreign for you, that's okay. You can use your teacher's method. That's totally fine. This is just, for me, if you're watching this video, it's because you're struggling, and this is the best way that I can help you if you're struggling. Okay, so I'm going to work my way backwards through this list, doing the opposite operations. So the very first thing that I'm going to do is I'm going to subtract 14 from both sides of the equation. Okay, so 14 minus 14, that's going to equal 0, just leaving us with the 5x equals the negative 16 minus 14 is negative 30. And that took care of that step right there. Next, I need to do the opposite of multiplying by 5, which means I need to divide by 5. And that will cancel those out. Negative 30 divided by 5 is negative 6. Now, I don't need you to do that for this section, or do this for this section, but I just want to make a claim here so that you understand what that answer means and you could check your work. And you probably should check your work. I don't have a lot of space to check my work. Well, I'll do it anyway. What I'm saying here is that if I replace the x with a negative 6, that this whole statement will be true. I'm going to get the same thing on both sides. So let's try that out really fast. 5 times negative 6 plus 14 equals negative 16. So 5 times negative 6 is negative 30. Plus 14 equals negative 16. And if you do negative 30 plus 14, you're going to get negative 16. So there's my answer right there. All right, let's go ahead and look at question 4 now. Question 4 has a different 2 steps. You see how I solved this in 2 steps? I subtracted 14, and then I multiplied by 5. That's what we're going to kind of do over here. So again, I'm going to set up my box, but there's a problem here. I have 2 x's. I cannot fill out this box until I have only 1 x to write about. But this is really easy, and the whole reason why we did that first week, the expression simplifying, is because I needed you to see these are like terms. They're like terms on the same side of the equal sign. So I can just put them together. So 5x equals 10. Now I only have 1 x. I could write what's happening. It's being multiplied by 5. And so I'm going to divide both sides by 5. Divide by 5, divide by 5. And we're going to get that x equals 2. In other words, 2, if I replace the x's with 2, I'm going to get the statement to be true. So I'm going to try that just to check my work. 2 times 2 plus 3 times 2 should equal 10. Well, 2 times 2 equals 4, and 3 times 2 equals 6. And if I do 4 plus 6, I get 10. Good deal. There's our correct answer right there. All right. Oh, that was awkward. Let's come up here and do question 5. Question 5 says 2x plus 9 equals 1. Well, I only have 1x, and I'm solving for x, so let's go ahead and make our box. I'm going to label it with the x for today. It's going to make more sense in a couple of lessons. But I'm going to start closest to my letter, and I'm going to work my way out, writing the numbers and the operations that are happening to x. So the very first thing that I see happening to x is that it's being multiplied by 2. That's the closest thing to it. After that, it's being added by 9. Okay? Now I'm going to do the opposite operations, starting at the bottom and working my way up, just like we did on question 2. So the very first step that I'm going to do is I'm going to subtract 9 from both sides. When I do that, these are going to cancel out. We're going to get 2x equals negative 8. And then I'm going to divide both sides by 2, because I already took care of this step, so now I need to do the opposite of multiplying by 2. So I'm going to divide by 2, and x is going to equal negative 4. In other words, if I replace the x with a negative 4, that statement is going to be true. Let's just double check. 2 times negative 4 plus 9 equals 1. 2 times negative 4 is negative 8 plus 9. And negative 8 plus 9 does equal 1. We're in good shape there. Okay, so, I don't know why I erased that. There's your answer right there. All right, let's go down to question 7. Question 7, same thing, except when I go to make my box, I have 2 different x's. I cannot make my box until I get rid of one of those x's. Well, we're in pretty good shape here because these x's are on the same side of the equal sign. This is just an expression that I could simplify. Well, if I have 3 x's and I take away an x, I get 2x equals 18. X is being multiplied by 2, so I'm going to divide both sides by 2, and x equals 9. So if I replace the x's with 9s, I should get 18, and I'm going to double check because that's a good habit to get into. 3 times 9 minus 9 equals 18. Let's find out. Well, 3 times 9 is 27 minus 9, and yes, 27 minus 9 does equal 18. Alright, so my answer that x equals 9 is totally right. Okay. Let's go to question 9. Question 9 is going to be a little trickier than anything we've seen. Once again, I'm setting up my box. I'm solving for x. This time I have 2 x's, but they're on opposite sides of the equal sign. Okay, so that's tricky. Now, what I teach my students might be different than what your teacher teaches your students. You know what I'm saying. My method might be different. What I tell students, if you have 2 x's on opposite sides of the equal sign, look at the coefficients. Okay? If you look at the coefficients, you want to find which coefficient is a lower number. Sometimes you've got to be careful if you've got negatives. Negatives are always smaller than positives, even if it's like a huge number. But in this case, we just have a 6 and a 3, and you want to ask yourself, okay, which one is smaller? To me, 3 is smaller. So what we're going to do is we want to move this to the other side. But within an equal sign is kind of like blocking it. You can't just combine these two things together. You've got to do something special to move it. So if I'm going to move it, I need to subtract 3x from both sides. Okay, it's kind of like doing the opposite kind of a thing again a little bit. But if I take away the 3x on this side, I'm going to take away 3x on that side. I'm going to have 3x equals negative 9. Okay? Some teachers will just tell you in equations that look like this to always move this one over here, and that's totally fine. We could have done this a different way. You could have subtracted 6x from both sides, and you would get that 0 equals negative 3x minus 9, and you could have solved it that way too. That's totally fine. But for me, it's always just easier to look for the lower coefficient and to move that, get that to the other side, or to eliminate that from your side of the equation. So what did we have? We had 3x equals negative 9. Well, now we know that x is being multiplied by 3, so I'm going to divide both sides by 3, and I get that x equals negative 9 divided by 3 is negative 3. Now what that means is if I replace my x's with negative 3's, I should get the same thing on both sides. So let's go ahead and try. 6 times negative 3 is negative 18 equals, what is that? 3 times negative 3 is negative 9, and then we still have minus 9. Well, negative 9 minus 9, oh sorry, this was negative 18. Negative 18. Negative 9 minus 9 is negative 18, so this was the right answer. Alright, question 11. Question 11 looks intimidating, but don't let it intimidate you. It's just the same as everything else. We only have one x. The closest thing to it is it's being multiplied by 2 and divided by 5. So I'm going to do the opposite steps backwards. I'm going to multiply both sides by 5. So I would get 2x equals 30. And then I'm going to divide both sides by 2. And I would get that x equals 15. If I replace the x with a 15, I'm going to get the same thing on both sides. I'm also going to talk to level 3 students here in a second to show you another way you could have done this. So 2 times 15 divided by 5. Well, hopefully that equals 6. 2 times 15 is 30. And then 30 divided by 5 does equal 6. So we're in good shape there. Now level 3 students, in the last video, I think, or a couple videos ago, no, in the last video, we talked about how 2x divided by 5 is the same as 2/5 x. So I could have rewritten that equation like that. And there are different ways that we could have solved it. We could have used the box of doom to say, hey, x is being multiplied by 2/5, and you could have divided both sides by 2/5 in your calculator, because 6 divided by 2/5 can be tricky. And you could have typed 6 divided by 2/5 like that into your calculator. And your calculator would tell you that x equals 15. That's one way to do it. Or another way level 3 students and I have talked about is we have 2/5 here. If I want to get a 1 next to that x, well, I can just multiply that by the reciprocal, by 5/2. And I could do that over here too. This will equal 1. And then 6 times 5/2. Well, we would multiply the tops and the bottoms, and you would get 30/2, and 30/2 is 15. So 3 totally different ways to answer that question. Hopefully you found one that works for you. Let's see. Do I want to... Let me look on the next page and see what I've got going on there. Okay. This is a little rare, but I want to reward you for watching this video. We just found out the answer to number 11 was x equals 15. Okay, I want to actually answer question 10 for you. It's not on the answer key, so this is like a bonus answer you're getting. But, yeah. Anyway, one way to solve this is the box of doom by saying that x is being divided by 4 and added by 2. That will get you the right answer, no problem, no sweat. Some people get really nervous. I call it fraction anxiety. Oh, and hey, this is another method we could have used to answer question 11. I'll show you that in a second. Some people get really nervous when they see a fraction, so I teach them this crazy method where you can circle the bottom of a fraction and multiply the other terms in the equation. So I want to multiply that here, and I need to hit this stuff over here. But I'm going to leave the top of the fraction alone. That's just going to come down by itself. So essentially I'm multiplying everything in this equation by 4. Because if I take x divided by 4 and multiply it by 4, I would just get x. That's what's happening in that first part. Then I would have 4 times 2 is 8, and 4 times 1 is 4. And I can subtract both sides by 8, and I would get that x equals -4. That's the answer. Let me show you that method works. If we did the box of doom, we would also get that same answer. So x is being divided by 4 and added by 2. I'm going to do the opposite stuff backwards. Okay, so I'm going to subtract 2 from both sides. So x over 4 equals -1. And then I'm going to multiply both sides by 4. And -1 times 4 is -4. Same exact answer. Okay, so there's that trick, and that also would have worked over here. If I had circled that 5 and drawn an arrow, I would get 2x equals 30, divide both sides by 2, and x still equals 15. Now, if you do that over here, if we circle this 4, we want to leave the top of the fraction alone and just draw an arrow over here, so you get x plus 5 equals 4, and I'll let you solve that from there. I don't want to give you too many answers. Okay. Let's go to level 3. I'm going to use that same method. Lots of different ways to solve these questions here. Okay. For those of you doing the box of doom, one way that you could do this is say, hey, x is being multiplied by 1/4 and then added by 5. You could solve that backwards. For some people, you're more comfortable if you move the x to the top of the fraction, so that you would have x divided by 4 plus 5 equals 1. In that case, you would say that x is being divided by 4 and added by 5, and you would solve that doing the opposite stuff backwards. Or you could do some kind of a mixture of both of them. Why don't I do this? I'm going to bump that x to the top, and since it's 1x on the top, I'm just going to write it as an x. Oops, divided by 4 plus 5 equals 1. I'm going to do that fraction anxiety thing where I get rid of this fraction just to show you that it also works along with the box of doom method. And that would get us x, sorry, I'm going to run into this down here, x plus 20, 4 times 5 is 20, equals 4. Subtract 20 from both sides, and you would get that x equals negative 16. And again, it would be good to double check our answers. We're saying that x equals negative 6, x equals negative 16. Is that what I said? Yeah, that is what I said. So if I replace the x, and I always go back to the original equation with a negative 16, 1/4 times negative 16. If you need a calculator, that's fine. Or again, we could put that on top of the fraction. So we'd have negative 16 divided by 4. That's going to equal negative 4. Plus 5 equals 1. And negative 4 plus 5 does equal 1. So x equals negative 16 was the correct answer there. Oh no, it's 20 minutes. Don't yell at me. Okay, now couple different ways that you could solve this. I want to get you started on some ways and then actually go through with it in other ways. Some people will look at this right here, and you recognize that 9x divided by 3 just equals 3x. Like that. Now, I can't use my box of doom until I only have one x. Well, I've got two x's here. There's an invisible one hanging out here. You remember what I said on the other page. If you have two x's on opposite sides of the equal sign, look at which coefficient is smaller. Well, a negative 1 is smaller than a 3. So for me, it's easier to move this over to the other side. The way that I would do that is by adding 1x. Add 1x. Because if you're gonna jump the border, you got to do the opposite side. Or you gotta like do an opposite kind of a thing. So to get rid of this negative 1x, I need to add a 1x. So that would give me 4x equals 16. Divide both sides by 4, and x equals 4. I want to solve that using a different method too, just for those of you suffering from fraction anxiety. I'm going to circle this 3. I don't draw any arrows to the top of the fraction. That's just going to kind of fall down. So I'm going to have 9x. 3 times 16 is 54 minus 3x, like that. Okay, now I still have two x's. I've got a 9x and a negative 3x. Don't forget that that's the same as plus and negative. Okay, so the smaller number in this example is the negative 3. So to get rid of that, I'm going to add 3x to both sides. So I would get 12x equals 54. Did I do that right? 9x, 3, oh, I don't think 16 times 3 is 54. Don't judge me. Hold on. 16 times 3, see, I'm human too. That's 48. Where in the world did I get 54 from? Oh my gosh, I am the worst math teacher ever. Okay, 48. That's 48 right there. So sorry. This is good. I was just realizing I was getting a different answer. Okay, now x is being multiplied by 12, divide by 12, divide by 12, x equals 4. And even if I got a different answer, let's say I kept that 54 and went through, it's always important to double check your answers using the original information. So I'm going to do that, even though I'm way over my time limit. Okay, 9 times 4 divided by 3 needs to equal 6 minus 4. 9 times 4 is 36, divided by 3. 16 minus 4 is 12, and 36 divided by 3 also equals 12. Alright, so there's your answer there. Okay, so a couple of good methods going on there. And then level 4, I'm going to leave that to be up to you. Level 4 students, you've got some work to do there. Okay, I hope you had a great day. Sorry I went 5 minutes over, but also hopefully you're seeing that equations are actually kind of cool because generally there are so many different ways that you could solve it. It's not just one way. So I'm trying to give you tools so that you can find a way that's most comfortable for you. Alright, I'll see you guys later.